Hello all, welcome to the channel DevOps Tech Stack yet again. A big thanks to all the people who are subscribing to the channel, and in turn it make me keep going and come up with new videos. A quick reminder to all of you that this playlist I have created keeping in mind that it should suits for both technical and non-technical background people, and also I am trying to keep my videos with short and crisp information. Now, talking about the previous 4 videos in this playlist, we have discussed all about software development lifecycle, what is DevOps and Agile method, DevOps day-to-day tasks and responsibilities, and the Jira software which comes under the planning phase of software development. If you haven't watched those videos yet, do check that out to be on the same page. I will share the link in description. So till now we discussed only about the planning phase. After that, as we discussed, we have other phases too. But to understand all those phases, operating system knowledge is must. Now let's talk about the agenda for today's video. That is, we are going to discuss below points. The first one is what is operating system? What are the tasks of operating system? A brief introduction on the different type of OS which are available in the market like Unix, Linux, Windows and Mac OS, and why Linux is needed for DevOps. Now let's discuss what is operating system. As we all know that computer understand the binary language that is in form of 0 and 1. So we humans can't directly interact with the computer, and hence operating system comes into picture. Operating system is a program that lets you interact with your computer. Hardware and operating system together decide what the entire system can do. It manages both the hardware and software resources. Two of the most common operating systems are Microsoft Windows and Mac OS. So what are actually hardwares? Hardwares are the physical components of computer like monitor, mouse, etc. Now let's see the flow on how user interact with the operating system. User will not directly interact with the operating system. They will ask the application installed on computer to perform some task that in turn will interact with the operating system, and operating system will query with hardware. And the same flow goes in the reverse order, and the application will provide result to the user. Okay. For example, as a user, you asked computer to create a file, then it followed this flow to process your requirement. Now let's understand about the task of operating system. Very first, OS can act as a file manager. That means it helps user to open, create, delete or close any file. Next is OS act as a secondary memory manager. What is that secondary memory manager? The good example of secondary OS manager is hard disk. OS help to know which space of hard disk is filled or empty. Third is process manager. Process is nothing but a program under execution. Like you are editing some file, means behind the scene editing of file is executing one process. So OS helps to execute or delete a particular process. Fourth is memory manager. That means the primary manager, not the secondary memory manager. Like for example, we have RAM. It helps to decide which part of RAM is filled or empty. Last one is OS as a CPU scheduler. Means OS will help CPU to pick up the process and execute it. Let's now discuss about the Linux evolution. I will not go in back history of it, but I will try to give you a brief understanding of the overall architecture so that you can relate further in the upcoming videos. Back in the time, programmers wanted to build an operating system that is free of cost and multiple users can access the system. So they come up with the Unix operating system. Using the same code of Unix operating system, which was freely accessible, companies started to build commercial or paid OS, such as IBM built its IBM AIX operating system, Apple brought Mac OS. Similarly, we have HP UX from the HP company. Like that, several companies built their own paid operating system. After a few years, a person named as Linus started working on an operating system that should be free of cost, as Unix was very old that time, and that operating system is nowadays called as Linux. People say Linux as an operating system, but actually it is a kernel. In short, what I have shown here is, as I told that Linux is a kernel, means Linux combined with the GNU. GNU is actually a collection of free software. Together, if they combine, they make a operating system, and so we call as a Linux as an operating system, but actually Linux is a kernel and that is a part of the entire operating system. Linux is an open source operating system, and many companies started building their own operating system. Like Red Hat company built the RHEL operating system. Then from the some groups we have Fedora and Debian operating system. Similarly, we have Ubuntu and CentOS operating system and Amazon Linux operating system that we are going to frequently use on the AWS machine when we will create instances on the AWS cloud. Similarly, we have Ubuntu operating system that is mostly supported for the Kubernetes cluster environment. Then we are using CentOS that is very fast and are frequently used for the demo purpose. Now let's discuss about the very important point for the today's video, that why we need to learn Linux for the DevOps. The very first point to use Linux OS is that it is free to use. Like for example, we have Microsoft Windows, which is a paid operating system. We need to renew our license yearly. No other distributions are available for Windows, but for Linux, we have multiple options from different groups like Red Hat, CentOS, or Fedora. Also, Linux is freely available and no need to renew the license. Also, the second point is that Linux is secure, but for Windows, we need to put antivirus. Linux performance is very good because here we interact through the terminal instead of graphical user interface. We are going to see all this in the upcoming lectures in detail. The next point is software update is very easy. That also we will see in the upcoming lectures. Linux is lightweight OS. It takes less space in the RAM, so it is very fast and its performance is good. Multiple users can work together and access the same server same time with the same performance. Also, this is the architecture of overall Linux system. User will interact with the shell to perform some action like opening a file, and kernel interact with the hardware to complete that particular task. In case of Windows, in place of kernel, we have the operating system as we discussed in the previous slide. So to kickstart our journey with DevOps, Linux is the foundation and very important to know. As we are not the Linux admin people, so we will not get into deep dive of the Linux. But the basics of several aspects in Linux is must to know. Like we will understand what are package managers, what are users and permissions in Linux, what are Linux file systems, networking, SSH, shell scripting, and few more. Now to practice all the concepts in real time, we need a Linux machine. So I have decided to create a virtual Linux server on AWS cloud so that we all can be on the same page. To all the people who are hearing the term AWS Cloud for the first time, don't worry, it's just a cloud provider and we will get into detail of this in later videos. Advantage of creating virtual Linux server on AWS Cloud is that whatever commands I will be sharing will work for all of us and we will not get into any trouble related to machine configuration. Before creating virtual machines on AWS Cloud, we have to first understand what are virtual machines and how it works. So basically computer has hardware like CPU, RAM and storage, and top of that we have Windows or Linux operating system that decide how application will use hardware resources, and above that we have the application layer. This all we have discussed in our last video. If you haven't watched that video yet, please check that out. I will share the link in the description. Now let's say you want to install Linux operating system to learn Linux concepts. So for that, in normal scenario, you need a complete new system. But in modern era, we have a new technology called as virtualization, which enables that you don't need a new hardware. Instead of that, you can use the existing Windows operating system. You can install a new operating system using the technology called as hypervisor. Now we will discuss in detail of what is hypervisor. Hypervisor is basically a technology that allows to host multiple virtual machines on a physical computer on top of the operating system which you already have. One of the most popular hypervisor is Oracle VirtualBox from the Oracle. It is so popular because it's open source and free of cost and works on any operating system. What VirtualBox actually does, it takes the hardware resources from the host operating system. Hypervisor will actually create the virtual CPU, virtual RAM, and virtual storage for each of the virtual machines. It will give only those resources what exist on the physical machine. So in short, you will have one physical machine and on top of that, you will have multiple virtual machines by sharing the resources of the physical machine using the technology like hypervisor. Okay, for example, Oracle VirtualBox. These virtual machines are isolated from each other. Each virtual machine will consider themselves as a single machine, and that's good because anything happen on one VM will not impact the other VM or your physical machine. You can destroy that particular VM and create a new one. Using the technology like Hypervisor, you can have more than one operating system in a single physical machine for your testing. This is actually the type 2 hypervisor, what we discussed just now. What I am trying to make you understand is that you have one physical machine, just like what you have your personal laptop, which can be touched. And on top of that, using the technology like Hypervisor, you are launching multiple virtual machines that are isolated from each other by sharing the resources of your personal system. Why it is called a virtual machine? Because these can't be touched, but it exists in the reality. Now let's talk about the type 1 hypervisor. Those are called as a bare metal hypervisor. Only the major difference here is like hypervisor is directly installed on top of the hardware instead of the operating system. Here you will not see any of the operating system layer. These are actually called as the bare metal hypervisors. They are mostly used by the big companies where they have one physical server, and on top of that they will install the hypervisor technology. Few examples are VMware ESXi or Microsoft Hyper-V. This is actually used by the big cloud provider to create and run multiple virtual machines. So whenever we create a virtual machine on AWS Cloud or GCP, you are creating a virtual machine on a physical server, and other users also may create the virtual machine on the same physical server, but all those virtual machines, as we discussed, are completely isolated from each other. They don't share the network or storage or anything. Major benefit is that you can effectively use the hardware resources because they will be having the servers with a high configuration. Cloud providers let you decide how much resource you need for your virtual machines. So now as we have understood what is virtualization and how cloud providers are actually using this concept, agenda for today's video is to first create an account on AWS Cloud, secondly launch our first Linux servers, and at last we will see how to connect with that particular machine. Very first thing is how to create an account on AWS Cloud. As I already have my account there, so I will quickly go through the process for your convenience. It's pretty easy like how you create your Gmail account. When we create our account for the first time on AWS Cloud, it asks for the credit card information. It is just for the security purpose and nothing to worry about. Whenever we will launch a machine on AWS Cloud, we will select the free tier eligible ones and also with less configuration so that we will not be charged for the same. Also, this I will show when I will launch our first machine on AWS. Also, once our lab is done, we will destroy that machine and create a new one whenever required so that we will not be charged for any machines created on the AWS Cloud. To sign up for the first time on AWS Cloud, go to the link https://aws.amazon.com. Now click on create an AWS account. Here you will see a new page asking for your email address under account name. Let's enter the email address. Email address is just your Gmail address. The next is the account name. Account name is just your name or some random name. Let's say I am entering DEVOPS-demo. Then click on the verify email address. It will send a verification link on your Gmail. You need to click on that link and verify the account. Once the link is verified, in the next page, it will ask for your detail like your name, mobile number, and your credit card information. You can provide those details and your account is ready for use. This is just like how we create a new account for the Amazon online site. So once your account has been created after entering the password, Gmail account, everything, then you can log in into the existing AWS account. Click here. Here you need to write the same email address which you have used while creating the account, and then click on the next option and it will ask for the password. You need to enter the same password which you have set during creating the account for the AWS Cloud. And then you are ready to go and your AWS Cloud page will open and you can provision a new Linux server over there. I hope till this point you are very clear, and we will get into the next topic, that is how to provision a Linux server on AWS Cloud. So once you have created your account in AWS Cloud, we will sign up into the AWS Cloud and we will land up into this particular page. And here we will start creating our Amazon EC2 instance. So what is Amazon EC2 instance? It is nothing but a virtual server in Amazon Web Services. It stands for Elastic Compute Cloud. It is actually a web service where an AWS subscriber like you have just created an account can request and provision a compute server in AWS Cloud. So to create an Amazon EC2 instance, we need to click on the services and then the compute tab. Here you will see the EC2. Click on the EC2 option. This will launch the dashboard for EC2 and currently you see there is no instances running over this account. On the top right corner of the EC2 dashboard, we will see the AWS region where we want to provision our EC2 server. For now, I have selected the Ohio region. We have these many regions where we can create our EC2 instance. For now, we will just click on the launch instance option. The very first thing which we will provide is the name for our EC2 instance. Let's say I am giving it as a name as a DevOps demo. The next thing is AMI. What is basically a AMI? It is a template, basically the operating system platform, which you can use as a base to create your instance. It can either be a CentOS image or Ubuntu image or Amazon Linux server. This all as we have discussed in our previous lectures of DevOps Bootcamp playlist. Once you launch an EC2 instance from your preferred AMI, the instance will automatically be booted with that desired OS. So for now, I am selecting the Amazon Linux servers. We can also select Ubuntu, macOS, Windows, Red Hat Linux, anything we can select. But for now, I am just selecting the Amazon Linux. In the next section, we need to select the instance type. What is basically the instance type? It will basically let you decide how much CPU you need, how much memory you need. All those kind of details we can select based on the instance type. Like for example, if I'm selecting T2.micro instance type, I am getting one CPU and 1 GB of memory. And the best part is that this particular instance type is also eligible for the free tier. So we can select this particular instance type. Now here we need to decide how many number of EC2 instance we want to launch with this particular instance. We can provision up to 20 instances at a time. But for our case, it is just for testing purpose. So we will just create one particular instance. In the next step, we will be asked to create a key pair to log into your particular instance. A key pair is actually a set of public and private key. AWS stores the private key in the instance and you are asked to download the private key. Make sure you download that particular key and keep it safe and secured. If it lost, you cannot download it again. First, we will click on create new key pair. Then give a name to your key. Let's say I am giving the name as DevOps-demo-test. And then we will click on create new key pair. So by default, your key will also be downloaded in your local machine, which we will see later how to use it to log into your instances. Once your key is downloaded, we will select that particular key in the key pair name. Also make sure you keep this particular key safe so that next time whenever we will create a new EC2 instance, we will select this particular key only for logging into the EC2 instance. Now we have few more sections also, like what are network settings, what are firewall rules, what are the storage options. All those things I will not get into deep dive as of now. Once we will learn all those concepts in a Linux machine, I will show you how it all works in the AWS also. And finally, we will click on the launch instance. Now click on the view all instances and you will see that this instance is now in pending state. Wait for it to be in the running state. As you can see, now the instance is in running state. We can log in into this instance using the SSH. I will show you how to do that. Now the very first thing is we will try to log in into the EC2 machine in Mac. For that, we will have a SSH protocol that allow our local computer to connect with another machine. All this SSH protocol concept we will see in the networking section in more detail. For now, we will just open this particular instance or select this instance. Click on the connect option. You will see here the SSH client tab. Here you need to have one command which will allow to log in into this particular instance using the SSH protocol. So first you need to open your terminal. This is our terminal. And inside the downloads folder, I have downloaded this key as I have shown previously also. This is the particular private key that we will use to log in into the EC2 machine. Now first you need to give the permission to this particular pem key. We will copy this particular command. This chmod command in detail we will see in our next lectures. Just paste that command. After the proper permission has been given, you need to copy the next command. This is the next command. You just copy this, paste it over here. So what we are doing in this command is the first one is the SSH protocol. After that, we have -i argument. In that, we are passing the private key name. After that, we have the EC2 user. This is the username with which we are connecting to our EC2 instance. After that, we have @ which is the separator. And then this is the host name for this particular machine for our EC2 instance. Now click enter. Just type yes. Now, as you can see, now we are inside the shell of the EC2 instance. So this way I have shown for all the people who are using a Mac system. But I know most of you will be having a Windows machine. So to log in into the EC2 instance, we need to download the putty software in the Windows machine. I can't show that particular demo as I don't have a Windows machine, but I will go through one block for your understanding. I will share this particular link in the description. You can go through it and accordingly you can download the putty software and configure it to log into your particular EC2 instance. We will quickly go through this particular block. The very first thing which you need to do is to install a putty software in your Windows machine. This is the download page for your putty. You need to download it here. You need to click on download it here option. Once your putty software is downloaded in your Windows machine, you need to follow the next sections. After that, what you need to do is the pem key which you have downloaded in your local system, you need to convert it into .ppk file using the puttygen. Once you download the putty software, it will give you a tool as puttygen. You need to open that puttygen tool by going into the start menu. There you can choose all programs. Under that you will find the puttygen. After that, you need to click on this RSA option. Here you need to select all files option and then you need to select your .pemkey file. After that, you will see the option to save that particular file, and puttygen tool will by default save that file as a .ppk file extension. Once this file has been downloaded, what you need to do is you need to open the putty from the start. From the start menu, again open the putty software. What you need to do here is you need to pass the host name. This is the host name which you need to pass over here. Then SSH always connect on the port 22. So here you need to write the port 22. It will be by default. After that, in the category section, you need to click on the connection and there you have option as SSH. In SSH, you need to pass your ppk file which we just converted using the puttygen tool. That you need to pass, and then you finally need to click on the open section. Once you have clicked on open, you will see that you are connected to the EC2 instance. I hope this video was pretty useful for you as we are going through the very basics till advanced in the DevOps Bootcamp playlist. See you in my next video where we will understand all the Linux concepts which we need to know as a DevOps engineer. And also we will do all of them practically. Guys, also I'm planning that with all the Linux concepts, I will parallelly take real-time shell scripting course also. Do let me know in the comment section how is this idea. Till then, don't forget to like, share and subscribe my YouTube channel DevOps Tech Stack, and you can connect with me on Insta too. Thank you.